बिस्मिल्लाहिर्रहमानिर्रहीम। आज का नेक्स्ट टॉपिक हमारा है एरर्स एंड अनसर्टेनिटी। तो इससे पहले एरर्स के बारे में देखते हैं, एरर होता क्या है। तो बेसिकली एरर इज द डिफरेंस बिटवीन द मेजर्ड एंड द ट्रू वैल्यू। हम एक बार हमारे पास एक्चुअल वैल्यू है, हम एक वैल्यू मेजर करते हैं, उन दोनों के दरमियान जो डिफरेंस है वो एरर है। तो तो रेंज ऑफ रीडिंग्स क्या होगी, तो स्मॉलेस्ट और लार्जेस्ट वैल्यू के दरमियान जो मेजरमेंट के दरमियान जो वो रेंज होगी। So we have the two categories of the error, that is random error and the systematic error. So first of all, what is a random error? Whenever there is a random error in your measurement, we don't know the exact source. For example, you are taking the time period of pendulum. So at every swing, you are going to measure the time period of the pendulum. Its swing is going to reduce. Whatever the vectors are, for example, might be there is a blow of wind, might that there is a change of temperature, might be there is a change of humidity over there. So we don't know the exact source of that error. So the first point, readings are scattered on both sides of the true values mean that, let's say, I have a graph like this, and I have a scattered data, and I have a line of best fit over that. So let's say this is a true value. So data is scattered on both sides of the true value. Okay. So if I want to reduce this type of error, I have to take the average. I will not take the time of the one swing of the pendulum. I will take the time of the 20 pendulum, 20 swings of the pendulum, and will divide that number by 20. So it is a part of a human error. So we can say that random error might be caused by the error called parallax error. So if you are measuring volume of a liquid, so if you are not at 90 degree to the measurement or the perpendicular to the reading, then you are having some error at some angle. So that type of error is called a random error. Going toward the systematic error is a sort of type of error in which, let's say, you have your instrument is giving zero point 0.2 millimeters more measurement or zero point 0.2 millimeters less measurement. So this part of the error will occur at every measurement. So this error is called systematic error. So as written over here, it is on one side of the true value. Let's say there is a cylinder like this, and you are going to measure its diameter every time. So that instrument has 0.2 centimeter of error. Let's say this measurement was 2.2, that measurement was 4.2, that measurement was 6.2. So at every measurement, this error will occur at the same interval. So this error cannot be reduced. We have to remove this error by taking that measurement and removing that error from the final measurement. So this error occurs systematically. This error occurs in the equipment, and this is due to the non-calibration. So moving on, this was only the type of error which we see in the A levels. Now moving on to on the uncertainty part. Now, as we see that there is an error, we will go and see what is uncertainty. So basically, in a very simple term, we can say that uncertainty is basically a range of error. What is mean? We will take a simple example. Let's say we have an industry which is going to make some resistors, and he says that I'm going to make a 80 ohm resistor, and I'm going to make 1 million of 80 ohm resistors. So by theoretically and practically, we can see that at every machine, it cannot combine the exact number of atoms. There will be a little difference between at every resistor value. So it gives a range of error. Let's say company says that we have 5% range of error on in every resistor. So this range of error or range of interval of error, that is called uncertainty. We are uncertain about this value in the AT on the resistor. So we there are basically two types of uncertainties. Number one is percentage uncertainty. And if we want to find the actual value of that error, So we will take the 5% of 80 ohm resistor. That will be 4 ohms. It means that the company claims that our resistor value can range from 676 ohms to 84 ohms. So this part of the writing that is called absolute or actual uncertainty. So these two are basically two equal things, but we are expressing the terms in different forms. Another rule, if I that was the part if I wanted to convert it from percentage to actual, but if I want to convert it back, so I will take the absolute uncertainty divided by the actual value times 100. Then I will be converting that value into the percentage uncertainty. Now we will take some example to understand this type of questions. Now there is a question. Yes, over here. He has given the question that the volume V of the liquid flowing in time t through a pipe of radius r is given by the equation. He has given some equation and he has given the measurements of all the variables in that formula. Now see over here, what he is saying that calculate the value of C. First of all, the first step to do such type of question is to see the formula. We have to make the subject C over here. The formula will be V over T is equal to pi P R4 over 8Cl. Now, for the value of C, make the subject C pi P R4 over 8 times L times V over T, because he has given the value of V over T. Okay. You now the main thing in this type of question is when he is asking to calculate the value of C, just put in the actual values of the each measurement, not the uncertain part. Leave that part. Just substitute the values over here. As you can see in the mark scheme, he has given only substituted the actual values over here and just calculated the exact value of C, that is 1.04 times 10 to the power minus 3. You can do it by yourself. Now, I can write this value over here directly. 1.04 times 10 to the power minus 3. Now he's saying that calculate the uncertainty in C. First step, do it one stepwise. Step number one, write formula. Formula was C is equal to pi P R4 over 8L V over T. Step number one, when you are going to find the uncertainty, just remove the constant values because the constant values have no uncertainty. So I'm going to remove pi and 8. Now remaining part is P, R4, L and V over T. Second step, whatever the formula is, the variables are being multiplied, divided, whatever. You are going to calculate the percentage uncertainty first. You are going to add all the percentage uncertainties of the variable. So I will write percentage uncertainty in P plus percentage uncertainty in R4 plus percentage uncertainty in L plus percentage uncertainty in V over T. Now, as I have told you earlier, to calculate the percentage uncertainty, you have to, let's say in case of P, you have to divide absolute uncertainty divided by actual value times 100. Okay, I will write over here. Just give me a minute. So values are 0.05 divided by 2.5 times 100 plus, that is R4. So 4 we multiply So in case of percentage uncertainty, remember this, he has given us the value of R, not R4. So we have to multiply the power before the variable, then we find the percentage uncertainty in R. What are the values of R? 0.01 divided by 0.75 times 100. Likewise, for L, now you tell 0.01 divided by 0.25 times 100. And for V over T, we will have 0.01 divided by 2.5. So when we calculate all the percentage uncertainties, I think the value will come like, if we add all the, it will be, the value will be 8.6. So I'm writing directly over here. You can calculate by your calculator. The percentage uncertainty is 8.6. Now, what will I do? In step number 3, I will take 8.6% of the actual value of C, that is 1.04 times 10 raised to power minus 3. So what answer I will get? I'm writing directly over it, that answer will be 0.09 times 10 raised to power minus 3. I hope you got the point. Now in part C, state the values of C and its uncertainty to appropriate number of significant figures. Now see over here, as in part C, the answer is 0.089. I have 3 significant figures over here, so I have to, or you can say after the decimal part, we have only 2 figures over here, so I have to round uh, up to 2 decimal places. So I will round it to 0.09. I hope you have got the idea. Another question, I can do it for you over here. Here, see, he's saying that time period T is given by this value. Determine the SI base units of K. It's very simple. How can you compute the SI base units? You first step, write the formula. P is equal to under root A R cube over M. So take the square root on both sides, you will get T square is equal to K R cube over M. And you can do like this, K is equal to T square M over R cube. So second square kilogram over R cube. So these are the base units simply. Now he's saying that to calculate value of K and its actual uncertainty. As I told you earlier, take the formula T square M over R cube. And if you are calculating the value of K, just substitute the actual values and leave behind the uncertain part. So in the T, you will substitute 8.64 times 10 to the power 4 square. 8.64 times 10 raised power square. For the value of M, you will write 6 into 10 raised power 24. And for R, you will write 4.23 times 10 raised power 7 and whole cube. And you will find the actual value. In here, I can see the value is 5.91 into 10 raised power 11. Okay. Now, for the uncertainty, as I told you earlier, if you want to calculate the uncertainty, whatever the values are, you are going to calculate in this part. It is also already given the percentage and uncertainty, so you don't have to convert into percentage. The percentage is always already given over here. So I can write over here K is equal to percentage uncertainty in T square plus percentage uncertainty in M plus percentage uncertainty in R cube. Now, in percentage uncertainty in T square, you can write it as as I said, the value of T is given, so power will be multiplied before, and the percentage uncertainty in T is 0.5% plus the percentage uncertainty is 2% plus percentage uncertainty will be 3. Power will be multiplied before, and the percentage uncertainty in R is 1%. So it will be 1 plus 2 plus 3. I will get 6%. Now I will take the 6% of this actual value calculated for K. That will be the uncertainty. So in this part, you can see 6% of K, that will be this. So the values are 5.9. I've taken one significant figure. So for this, I will take also one significant figure for the uncertainty. I hope you have got any all the idea of the uncertainty and how to calculate the type of uncertainty. If you have any idea or any question, you can ask. Till then, Allah Hafiz.